Welcome back, and let's start with looking at options that are not even listed in the detailed specifications for automotive oscilloscopes. There are such options, and to find them we have to go to the Picoscope user guide, and namely page 207, where there is a device feature table with all the features, and we find the 4225 and 4425 Picoscope, and then look for the check marks. The second check mark is AT, and this is just advanced triggers. Okay, so no surprise there. But then there is another check mark that corresponds to BL, which is a switchable bandwidth limiter right here. What is it? Well, it's an analog filter that you can apply by going to Tools, Preferences, Options before using your oscilloscope, and it will set a bandwidth limit of your choice, which will be below the bandwidth of the oscilloscope, which is, as you remember, 20 megahertz. How is this useful? Well, it can be very useful if you go to some location and find that there is some appliance that provides a lot of interference. You cannot turn it off, you just have to deal with it. And so what you can do is you go to this dialog, set your bandwidth limit to a somewhat low value, but still a few times higher than the frequency of the signals you are trying to capture, and you probably will not have such a big issue with the interference anymore. Very cool. But make sure that this bandwidth limit that you set is a few times higher than the frequency of your signal, and when you move on to the next project, make sure to reset this value, because otherwise what might happen is that you might still have this bandwidth limit set on, and suddenly you'll find yourself using your oscilloscope on faster signals. They will be really distorted. You will be running in circles figuring out why they look nothing like you expect them to look like. So be aware of this feature. It's useful, but also make sure that you do not accidentally turn it on and leave it like that. Okay, so what about the next one? What is this check mark for? FC. It's frequency counter. So it's a unique feature for automotive oscilloscopes that in the menu where you typically select AC or DC coupling, you can also select frequency, where it enables the frequency counter and can plot it like that. This is somewhat unique to automotive oscilloscopes. Probably they added it by popular request to compete with other automotive oscilloscopes that have this feature. For all the other Picoscopes, this feature is not available, but you can still plot frequencies using the math channels, and we will be talking about that later on. The next feature is this one, LP, which means low pass filtering. It's a standard feature for many Pico oscilloscopes, though not all of them, and it allows you to enable digital filtering for each of the channels, and you select frequency for each of the channel. So if you collect some waveform and it has a lot of hash in it, an easy way to fix that is to activate this option, choose the appropriate frequency, and get a much nicer waveform. In the detailed descriptions, you see that they can use different filter type depending on the how the frequency that you set is related to the sampling rate. for many situations you will be in this situation where the frequency is going to be much less than the sampling rate, in which case the filter type is going to be moving average. So this is a very useful feature, and compare it to that feature that we discussed a little bit before, the bandwidth limit. That one was setting the bandwidth limit for all channels. This one, you can do the filtering for each channel separately. Okay, moving on. What else do we have? In this list, we also have RA, RU, and the SAM. And they are rapid triggering, run pulse trigger, and streaming mode. All of those we already covered in the previous parts, so we do not have to do that today. So we are done with the options that were not listed in the detailed specifications. I can move on. Or do we? Because there is another option that is called connect detect, and somehow it's not even in this table. Oh well, what is it? Connect detect feature is described on page 129 of the user guide, and it's available only for automotive oscilloscopes in DC coupling mode only. So the purpose of this is to indicate whether your test probe has a good connection to the signal that you are interested in. And not sure how it works, some crafty stuff with bias voltages or something, but it should be able to detect whether it's connected or not. And so there is a button in the Picoscope software that allows you to enable it for each channel. And if the connection is good, it will show you green. If it's not, then it will show you red. And I guess that's a very useful feature if it works as desired. You cannot use it all the time because, for example, it's not supposed to be used for the coil and plug probes. So be careful about those. Okay, now we are ready to move on with the specifications. So let's just go there. And the next one is spectrum analyzer. So it will plot the frequencies that you have in your signal and make a histogram out of them, all the way from DC to 20 megahertz. It's pretty much all implemented in the software. The Picoscope software is taking the buffer that you have, and instead of plotting it as voltage over time, it uses a fast Fourier transform to present you as a histogram. And it's typically used for audio or radio signals and analysis of those. And you can say, well, in automotive practice it still has application, because what you can do is you can connect a microphone to your oscilloscope and then do some noise and vibration analysis using that microphone and the scope combination. Check what frequencies are there, and maybe there's something that can give you an idea where to look for the problem. So just be aware that this option is available to you. Math channels is a very cool feature. It's also implemented in the software, so it should be fairly similar among different Picoscopes, because it's just what the software provides, and it provides the following capability. So you have some channel A, B, and so on. What you can do is you can use some sort of a mathematical formula to take the signals from those channels and mix them all up, sum them up, create a difference multiply one by another, even compute such things as frequency or duty cycle, and then plot them side by side with the original signals. Also available to you various filters, minimum, maximum, average, peak, and also you can shift the waveform by 1 second, 2 seconds, lots of different ways. And it can be very useful, for example, if you need to take the differences between two signals. It's very easy to do. You just have to say, okay, channel A minus channel B, and you can plot something like a voltage drop over a certain load. Very, very useful. Don't get carried away by the capabilities of this feature, because the resolution of its output is still dictated by the resolution of its inputs. For example, if you are doing some voltage drop test and you connect two probes to two locations, both voltages are, let's say, close to 12 volts, so you have to have your scope at plus minus 20 volt voltage scale, and there you, let's say, you get a resolution of about 10 millivolts. Your difference, one channel minus another channel, will have the resolution of about 20 millivolts. Even though the voltage difference is going to be small, maybe under 1 volt, the resolution of the output is going to be dictated by the resolution of the original input channels. So there is no magic over here. You have to be aware of the resolution and the precision of the output, which is directly related to the precision of your input. Now the section for automatic measurements, fairly standard stuff. So once you collected some buffer, you're able to calculate some statistics on that. So for example, display RMS values, the DC average, the duty cycle, minimum, maximum, and so on. So this is all done in software and should be very, very similar among different oscilloscopes. Now we are going towards the serial decoding, and this is also a software feature, and it differs in which protocols are being implemented in different Picoscope software versions. What's interesting is that for automotive scopes, the amount of protocols that are being implemented for decoding is much, much smaller than what's available for the Picoscope 2000 series. If you just scroll to serial decodings, we'll have about 2 lines of those, including one of the interesting protocols, the SENT protocol that I covered in one of the videos a while ago. It's an automotive protocol, and I do not see it at all in the automotive Picoscope specifications. I'm not sure if it's a typo or it got added later on, but if you have an automotive oscilloscope, please go check it out. Check the serial decoding options and see if the SENT protocol is missing. I really would like to know whether it's there or not in the latest software. Note that the serial decoding as implemented in Picoscopes is a totally software feature, meaning that the Picoscope software receives the buffer from the oscilloscope, examines it, and does the serial decoding on it. That can be different for the high-end oscilloscopes that cost $10,000, and what they can do is that they can do the serial decoding right inside the oscilloscope, figure out what's inside the packet and issue a trigger based on that information. So for example, they can examine a CAN bus, see if it contains error frames, and if it does, issue a trigger. Or they can go and check FlexRay, and if they see something in the header that has a specific value, they can issue a trigger, and you will get it shown on the oscilloscope. Very cool feature, very expensive, maybe more of interest to automotive engineers rather than automotive technicians, but good to know that such thing can be available. However, in Picoscopes, it's a software feature, so there is no way to do the triggering based on the serial decoding results. The next two features are mask limit testing and alarms, closely related to each other, often used together. They're both software options, so they should be fairly similar among different Picoscopes. Setting the mask allows you to do the following thing. If you do not use a trigger, then the typical use is to put the Picoscope into a streaming mode with a relatively large time base and let the signal run. For example, you expect it to be constant. So you set a mask around that voltage that you expect, and once the whole screen is captured, the Picoscope will check if that signal satisfies that mask. And if it doesn't, then an alarm is raised, upon which the waveform can be saved into a file, or the software can beep through a computer speaker and alert you that something unusual happened. I have an example of that being used for a parasitic draw testing. Another way you can use the mask is with the trigger. So you set up a trigger on a signal that is supposed to be repetitive and having very similar patterns. So you use the trigger to capture the signal and recognize its pattern and set up the mask around that particular pattern. Then if you let the Picoscope run, it will use a trigger to collect more and more of the patterns, and once that pattern is outside of the mask, you again will get an alert. So that is very useful for testing such signals as well. For data export, there are several file formats that you can export the waveforms. The native one is PS data and Picoscope settings, and this can be very useful even if you do not need the waveform itself, but it also saves all the settings for the channels, time bases, and also some triggers. So what you can use it for is, if you found a really good combination of the settings to do a certain test, you just save that particular waveform in a PS data file. Then later on you can always bring it back. You will have the template of the waveform that you expect, and all the settings will be correct. You will be ready to run the test all over again without any doubts about the settings. Very cool. But you do not have to save it to a PS data. You can also save it in a more common format like a CSV, comma separated values, or even TXT, so that you can share it with other people that can load it into different programs and see what's inside. Also, maybe even good for mathematicians that are using MATLAB. If you just want to get a picture, there is also options to save in BMP, GIFs, JPEGs, and even PDFs and PNGs. So lots of different options. Now we are almost done, and in environmental section, we can see that the temperature range for the Picoscope is from 0 to 40 Celsius, and to achieve the quoted accuracy, it's only from 15 to 30. Picoscope is not guaranteed to work outside of this range, which is fairly limiting for the mobile techs that can easily come to a car in freezing conditions. So the question is, well, from your personal experience, what happens to the Picoscope in negative freezing temperatures? Would be real fun to know whether it misbehaves and how it misbehaves. Obviously, I don't have that experience because I typically do not do stuff in the freezing temperatures. Alright, now there is a section about software, languages, usual stuff. There is something interesting in the general section. The warranty for Automotive Picoscope is just 2 years. And it's interesting to compare that with Picoscope 2000 series, that warranty is 5 years. So if you get a cheaper scope, you automatically get a better warranty. How it is possible? Not so sure. Probably just because the extended warranty for automotive oscilloscopes is a separate option. I don't know. That would be something good to know from the sales team. And this is it about the detailed specifications for Picoscopes. That has been quite a journey. I'm really glad that the Pico team decided to put such detailed specifications for the whole world to see. It's not often that you see such details for the automotive oscilloscopes. I hope the viewers also enjoyed the videos and learned about options they never knew existed. But there are lots and lots of other topics to cover, so thank you and stay tuned for future videos.